Can you hear me now, Alex?
Yes, yes.
Okay, awesome. All right, we are good to go. Uh, why don't you give us a little spiel about your speech and your a brief introduction?
Okay, so I'm Alexandru Militaru. I'm a master student and I'm in my last year of studies. I'm also working as a consultant for Symmetry investments. And I use D in my daily work. I'm generally interested in operating system and compilers. This is my second time at DConf. Last year, I've talked about how I use D to strengthen the security of a Linux kernel module. And this year, I'm gonna talk about one of the projects that we are developing at Symmetry called sil-cling. So we created a D-based domain-specific language called sil, and we use this DSL internally. The aim of the project that I'm presenting today, and which is called sil-cling, is to let us call C++ libraries from sil. And the key point, I would say, the key point of the project is the C++ just-in-time compiler provided by CERN and called cling that we are using. And this just-in-time compiler provides reflection information about the C++ code, and that's how we are able to call it.
So sil is the symmetry integration language, correct? That's the yeah.
Yes.
So can you give a little bit of background on sil before the talk starts?
This programming language, it's used mostly for bulk data processing and I think risk reporting. The aim of the language is to have a system where we can integrate all sorts of other languages and systems and be able to call it. It is used by our practitioners in their daily work. It's a language of functional flavor. I'll give more details in the talk, I think.
Okay, that's good. How did you get the job at Symmetry?
First, I had an internship for 3 months. I wanted to work a bit more on D because I'm not that experienced with D programming. I started 1.5 years ago with my bachelor project, and then I was really impressed by the D language. I thought that it would be a good thing to continue to use it in my project. So as I said, I started with an internship for 3 months, and after it, I continued.
Did you go through Razvan and Eddie's class at?
The D summer school. I suppose you are talking
Right,
about the
that's
D.
what. Yeah,
Well, the D summer school was created after
I see. I
after,
see.
but yeah, we have a very nice lab in University Polytechnic of Bucharest. I think there are about 20 people who are working on D, and the number is growing. We have each year new students who are working at projects that have to do with D for their bachelor projects, and I think there are about 3 students right now who are participating in Symmetry Autumn of Code, which is something like Google Summer of Code but for the D language. And yeah, it's we have a very nice collaboration with the D Foundation in our university.
Do you find any difficulty going between multiple languages in your job like that?
Not really. I really like this aspect because working with many programming languages and integrating different programming languages is something that I really enjoy. And yes, creating this plugin, working on this project to be able to call C++ from our internal language was really interesting for me.
So do you do any work on sil itself or just on sil-cling?
No, I'm not working at sil itself, but it depends. I mean, if I need something that I need in sil-cling, but it's not implemented yet in sil, I can write something and extend the sil's functionality.
Would you recommend this approach to other people who are trying to integrate different projects, different
What
languages?
do, what do you mean by this approach?
This approach that you're using with like the sil-cling in the middle, to load in the C++. It kind of acts like a buffer, right? Like a facade or whatever.
It's a tough question because this is a really particular case. It's about C++.
Well, okay,
Because
the reason I ask is because, I mean, we have some support for binding with C++ in D, but it's not complete. It's difficult. It's hard. So do you see this kind of approach as better, superior to binding directly with C++?
I'm not actually able to give an answer, but this approach, it's good because that's the only way we can call C++ from our DSL. But if you are using D, you can use these bindings for C++ without creating any other buffer. And
Well, I was just thinking, like in Java, you had like the Java native interface to bind with C and C++, and with D we can do it directly. But I just it's easy to bind with C. It's not so easy to bind with C++, and I don't know if we'll ever be there 100%. Walter, Attila, do you guys have any thoughts on that?
Yeah, I don't know if it'll be 100% either. This is why I haven't really worked in DPP for a while, because I'm not entirely sure how to progress given some of the things I saw and the difficulties actually getting them done. I don't know. I need to sit down and think about it and try to hack my way around it, but I haven't done it in a while. It's a tall order for certain things. I mean, if you have an OOP library in C++, it shouldn't be hard at all. It's when other features come into play that things get hairy.
Or do you guys have any plans to make sil? It's not open source, right? Sil?
no, it's not for the moment, but we thought about making it open source. The only thing is that it's pretty strong coupled with sil. So sil, it's obviously not open source. So we have to do some work on that. But there was a plan about that.
Do you process data with sil?
Yes, domain specific because it's used in a specific domain. Like,
well, right, yeah, I know.
yeah, these are general purpose because you use it for general purpose.
Yeah, I like what you're doing with the image facial recognition thing here. Can you talk about that a little bit more? Expand on what you talked about in the talk?
Basically, in that example, I'm using my plugin to call an open source C++ library called dlib. Dlib has face recognition algorithm. I just call it using sil-cling. I don't think there's much to add about it.
What about the network stuff? You were using ASIO. Do you guys do a lot of network programming?
Not really, but we are interested in various C++ libraries. So I thought that testing my plugin using Boost ASIO, because it's a well-known library, can be useful for in the first place for showing the power of sil-cling, and as a second point for finding bugs.
Attila, do you work with sil-cling at all, or with sil?
No and no. Whenever I have to do anything sil related, it's mostly to do with the implementation of the language. Really architectural stuff like, I don't know, low level implementation details, even organization of the source code itself. Right now, I'm focusing on getting it to build with Reggae, for instance.
So now you're talking about the Clang and LLVM interface.
That's the architecture of sil-cling.
Yeah. Did you have any issues getting all that stuff to play together nicely, to get it all to work together?
Yeah, actually, I didn't start the project. A colleague of mine, James Thompson, created the project, and much of the project from the architecture point of view, it's was done by them. But I had some issues with cppyy, because basically they are providing the reflection API over Cling for C++ code. And what happened is that the guys from CERN who developed this framework use a particular version of cppyy, but the cppyy master, it's created by some other guy, and they are not the same. For example, I had to take some specific bits from the upstream, some specific bits from the roots project's cppyy, because they took different paths.
So the cppyy, I had never heard of this before I saw your talk. And it's a wrapper around cling, originally created from your slide here, originally created for calling C++ from Python. How much of a learning curve was there for you to come into this project in progress?
I had many things to learn, because there was basically the layers that I knew before were LLVM and some of Clang, but the cling stuff, cppyy, and then obviously sil, because when I joined I didn't know about it. I had to look over everything.
Were you able to get up to speed very quickly, or did it take a long time, or what?
The code was very well documented, the sil-cling code, the existing code base, and I could make progress easily.
So this whole cppyy thing, from the slide, it says it provides the reflection mechanism. How do they do that? I mean, how did that Python library provide reflection from what, libclang? I don't understand how that's done.
From our perspective, we talk with cppyy, and we have some C++ code, and we tell to cppyy, well, I want to call this code, and cppyy takes it, creates a wrapper on the fly, and sends it to cling. And what cling does is to just-in-time compile that code, and once the code is compiled, obviously he can provide answers about its types, its functions, and so on. And what cppyy does is that it can query cling for you. I mean, I can call functions from cppyy and say, I want to know the return type of the function that I've just compiled, and cppyy will talk with cling, which has the AST, and will get that information back to me.
Performance is not an issue for you at all?
At the moment, it's not, but we plan in the future to have some profiling sessions. But no, for the moment, no, because the tool, it's not entirely finished, so we are still working on it.
Why don't you, is there anything else you could tell us to save me from struggling over here? Anything you could think of that would be interesting for people to know about sil or about sil-cling that you maybe didn't cover in the slide?
Yeah, maybe some people would be interested how because cling, it's some kind of interactive compiler or interactive interpreter or just-in-time compiler. I've seen all these names in the literature, in the papers, and maybe they are wondering how it's possible to have an interpreter for C++, because if you think about Python, you just write Python and you start coding there in the interpreter. And how do you do that? Because you can have expressions at the global namespace level of C++. And what cling does is to take the input that the user gives. You want to declare a variable and then to use it in a for loop at the global namespace level, the thing that you are not able to do in normal C++. Then Clang will complain, and what Cling will do, it has its transformation engine, and will take the error from Clang and the AST, and its transformation engine basically wraps the code in some functions as to be valid C++ code, and then those functions are called somewhere else.
I can tell you why.
Yes, please.
Please do.
The reason was that decades ago, a summer student, I think it was a summer student, it could have been something else. But anyway, a student at CERN wrote a C++ interpreter. And for some reason, people there thought it was a good idea to write scripts in C++. And they did this with the interpreter that the student wrote. And the reason Cling does any of the things it does is it can run the scripts that have been powering the research there for decades.
Yeah, I was actually going to ask about that because I remember reading about a C++ interpreter from CERN in a Wired or somewhere several years ago, and I was wondering if cling is the same thing or if it's a derivative project.
Yeah, it's basically a derivative project in the sense that let's do this the right way instead of writing our own interpreter. Let's use an actual C++ front end to do it, because there were a lot of problems with the old code in which somebody would write what they called macros, but basically the C++ script. And if you compiled them, they would work because it was C++. But if you try interpreting them, it wouldn't, because the front end was different and it was incomplete. And as Walter can tell you, writing a C++ front end is not a trivial task. And I don't know how long they worked on it, but they did, and then left CERN, and then people started writing scripts in C++, and God only knows how many millions of lines are there in these C++ macros, as they call them. And they had to make them still work. And if you JIT compile, then you could do away with a lot of the performance issues.
How many people do you have working on sil-cling right now? It's not just you, right?
It's me and a colleague of mine, but I think now it's only me.
And I guess the real question is, do you enjoy it?
Yes, it's pretty interesting.
What's the most interesting part of it for you?
Combining languages, working with D, Sil, and C++ at the same time.
People always ask on the forums, you know, like, can I use D with C++? What can I do? What can't I do? And I think nobody really knows the full story.
Maybe Walter can help us here.
Walter?
Could you repeat the question, please?
We're talking
I was
about
distracted.
Yeah, if we're interacting between D and C++, if you're binding with C++, I mean, what's the current state? I mean, what is it that you can't do? What is it? Do you know the full picture, or does anybody know the full picture right now?
Pretty much, if your C++ code is C with classes and templates, you should be able to make it work. If you're using more advanced features of C++, you may start having difficulties. So if you keep your C++ use fairly modest, you can make it work. And also, if you're willing to adjust the C++ side of things, the possibilities for connecting them get a lot larger.
Well, I'm just wondering what the possibilities might be of using something like cling and cppyy as a interface between D and C++. Attila, do you have any thoughts on that?
Yeah, I considered sticking it in DPP in a certain way, but what stopped me from doing that is, number one, time, and number two, unfortunately, when I wrote DPP, I broke my own rules, and I made it hard to do that, so I'd have to re-architect it first. Every time I break my own rules, I regret it later. Every time I say, it's fine, I know what I'm doing, no, I don't. Stop breaking your rules.
This is something that I asked you earlier, and I guess I confused you a little bit, but what would you think about using a cling-based project to interface between C++ and D, like Attila was just talking about? He thought about using it for DPP.
I think it would be but really interesting thing, because having reflection information about C++, it's really valuable, because C++ at the moment, from what I know, doesn't have a very generous approach to provide the static reflection. That's it. I think I remember discussing at some point with Atila, and he was complaining that there are some templates that he is not able to translate because he doesn't have some runtime information. But of course, with sil-cling, you can do that.
No, not exactly. Some things are untranslatable to D because they don't exist. To give an example from the C++ standard library, is reference T is a template that evaluates the true or false depending on whether the type you pass to it. So it's a meta function. It's a meta function that maps a type to true or false to a Boolean. Is this a reference or not? Now, D doesn't have reference types. So I can't write that template in D. It's impossible for me to do that. Now, not only does that exist in the standard library, as you can imagine, it's used in the standard library. And if it's used in an enable lift somewhere, I'm even more screwed. How do I write that in D? I can't.
I see, yeah.
I can't even humanly translate that. I, as a human, can't translate that template. Never mind the program I write to do that in the general case. And that's where I stumbled, and that's where I basically stopped working on it because I didn't know what to do after that.
Yeah, but you were trying to translate C++ code into D, but I think the point was the point of Mike's question was just to call C++, right?
Yes, but some things that are calling depend on the template stuff. So, for instance, Eigen is a library in C++ that uses expression templates, and I can't see how you can do that with cling at all. I mean, you'd have to write the expressions in C++ as a string and then pass it to cling. So I just don't see how that can work. And that's the issue. And why am I focusing on that? Because I want people to be able to migrate over to D from C++, but still use the same code, not have to give anything up. And that is the whole thing. I mean, this is the crux of my talk last year.
I don't think it'll ever be fully compatible, but it can be sort of, if you're willing to be flexible, you can make it work. They're like corner cases in C++ that are different from the corner cases in D. And, you kind of would need to stay away from those corner cases in order to be compatible. But for the pragmatic programmer, it's doable. Things like the ranges in C++ are very different from the ones in D, and being able to interact with the C++ standard library algorithms is always going to be difficult. Also, kind of maybe you're best off just looking at being able to exchange data back and forth easily, as opposed to the details and the subtle details. Like one came up the other day is how POD, plain old data, is defined. Well, it's defined slightly differently between the two languages. And if you're on that spot where things are different, you're going to have some incompatibilities. There's just no getting away from it unless you turn D into C++. And you make it an enhanced C++ rather than a different language. You can't alter semantics without diminishing interoperability.
Okay, Laith says here in the live stream chat, I think he's talking about sil-cling here. The main thing is that there's considerable overhead. It's not free, but it allows you to use C++ libraries to get a first working version quickly. If you need zero overhead, you can replace it later.
Yeah, I mean, I've also done a lot of interacting with C code, and that's fairly easy, but still there's a couple of edges where you need to, be flexible with interfacing with C in order to get it to work.
The only one I know of that's still left is macros that aren't easily translatable to D or at all, especially because macros in C and C++ don't need to be parsable code by themselves. They might need the context. So,
well, I ran into trouble with in converting C because C does not have the concept of modules, and in D you have a function can be declared in multiple places but only defined in one, and how you do imports and how you do separate compilation, sometimes you got to kind of shuffle things around a bit to get C to play nicely with a module system.
Yeah, my solution to that has been using DPP with only one include, several includes per file, but only one DPP file, because that way I just sidestep all of that, because I've had problems with that as well.
Right, but you're being flexible is what you're doing.
Well, I'm putting everything in one namespace in D, and that's fine.
Yeah, I mean, that works unless probably your code exceeds a certain size. I kind of wanted to keep the same structure of the code with the files and the header files, and I had to do some non-trivial reordering of things to get everything to work right.
Okay, this is Peter missed some of our discussion, and his question here is something that I asked about earlier, I guess. Can sil-cling be used from D to call C++ without having to go through the whole sil language? And Alex, your answer to that is?
My answer is that sil, I mean, instead of sil, I think there could be many other programming languages, but I'm not sure. I can't say about D, but I think we can call cppyy from D, that's for sure, and maybe we can use it. I think there's a good chance to be able to use it.
Okay, Laith said you could use cling to generate low overhead bindings and wrappers because it's tough for DPP to handle all possible headers and recursive includes. And regarding the open source, it says Laith says the D wrapper for cling is on GitHub, but it's a bit stale. Thank you very much, Alex, for taking the time to answer the questions and put up with me. So, anything you want to say before you go?
No, thank you very much for this chance, and it was a pleasure.
All right, thanks a lot, man.